In this video, we will understand how one computer on the internet can send data to another computer on the internet using the Internet Protocol. We will assume that you have already knowledge about a link layer protocol like Ethernet and MAC addresses, and how to derive network classes from IP addresses. For our example, let us assume that you are computer A, which has been assigned the IP address 67.68.50.1. From that IP address, we know that computer A is member on a network identified by 67.0.0.0. On that network, there is a special computer called router 1. As a computer in the 67.0.0.0 network, it has been assigned the IP address 67.68.50.13. Router 1 has also 3 more Ethernet devices. One, for example, has the IP address of 62.206.17.3, which indicates that router 1 is also part of the 62.0.0.0 network. For us, the 141.71.0.0 network is of particular interest. There we find router 2, which has the IP address 141.71.30.58. Like router 1, this computer is also a member of 3 more networks. For now, we have a closer look at the 205.34.55.0 network, on which our destination computer B with the IP address 205.34.55.1 is located. Let us have a quick look at the entire setup for the example of sending data from computer A to computer B. Like in the physical postal system, computer A needs to know the address of computer B. Computer A scans its routing table for the destination network 205.34.55.0, which hosts computer B. There is no such entry, but luckily the default route identified by 0.0.0.0 is set. The default route will always be used if we don't find our destination network in the routing table. The next hop identifies a computer in computer A's local area network to which the IP package inside an Ethernet frame should be forwarded. In our case, this is the router of the 67.0.0.0 network. Since IP addresses are not of any use for our link layer protocol Ethernet, we need to do an ARP request. ARP stands for Address Resolution Protocol and uses Ethernet to ask for the MAC address of the computer that is assigned the IP address 67.68.50.13. Besides the MAC address of router 1, computer A also knows its own MAC address. So now an Ethernet frame can be assembled using the 2 MAC addresses. As the data payload of the Ethernet frame, we will place an IP package which consists of an IP header and a data payload. Even though we will learn the complete structure of the IP header in the next unit, let me state that the source and the destination IP address are part of the data that are put to the IP header. So computer A puts the Ethernet frame on the shared medium of its local area network. From the destination MAC address, router 1 will receive the frame. From the ether type 0800, it will know that there is an IP package inside and also starts to read the IP header. Router 1 will now scan its routing table for the 205.34.55.0 network. This entry says that the data should be sent to the computer with the IP address 141.71.30.58. We recognize this address as router 2, which is sitting on our local area network of router 1. With this information, router 1 can now assemble a new Ethernet frame. In order to do so, it needs the MAC address of router 2, which will be retrieved by another ARP request. We realize that the data payload, especially the source IP address of the IP package, did not change. Even though router 1 does not have the IP address 67.68.50.1, the source IP address of the IP package will still stay the same. It is only the 2 MAC addresses and the checksum that changed. As before, the Ethernet frame occupied the entire network, and router 2, which had the destination MAC address, retrieves the frame and processes it. Router 2 is already a member of the 205.34.55 network, and thus there is an entry for this network in its routing table. Again, another ARP request is used to get the destination MAC address of the destination computer. The frame is assembled and put on the wire. The destination host can read the data and do a response, or whatever it wants to do. We have seen how to use IP addresses together with routing tables in order to interconnect local area networks and forward data through the internet. Especially, we realized that routers are like crossways of streets and just tell you to go left or right when you want to go to a faraway destination. I'm René Pickard speaking, and I hope this information was useful for you.